Cambridge IGCSE, February-March 2020, Paper 22. Solutions for question 16 to 20. Question 16. When pollen grains in water are viewed through a microscope, they are seen to be in continuous, rapid, random motion. What causes a pollen grain to move in this way? So, there are some pollen grains inside water. So, as you can see in a beaker, water consists of, and the water molecules are represented by these small dots, and these water molecules will keep moving in random directions, continuous movement. All the water molecules will be moving continuously in any direction, random direction. Now and here in the water beaker you can see a big sized pollen grains. So these are the pollen grains. These pollen grains will be continuously hit by these randomly moving water molecules. Because of that, what will happen to these pollen grains? They will also move in a continuous, rapid, random motion. The reason is the water molecules which is continuously hitting on these pollen grains in random direction. Now let's check what causes a pollen grain to move in this way. Convection currents in the water. That is wrong. Bombardment by a single molecule of water. It's not single molecule, but all the molecules will be moving randomly. So that the option B is also wrong. C. Uneven bombardment on different sides by water molecule. That is correct. Option D says collision with another pollen grain due to their kinetic energy. It's wrong. It's not because of the collision with another pollen grain, but it is because of the continuous collision by the water particles or water molecules. They are moving randomly. So the correct answer is option C. Question 17. A student measures the mass of warm water in an open container over 2 minutes. The container is kept at a constant temperature. The results are in the table. Why does the mass of the water change? So here, when you keep the water container open and the water is warmer, after some time the mass of the water is getting reducing. That means some of the water particles are getting reduced, or they are escaping from the water surface. And what is this process called? The escape of water molecules or water particles from the surface of water. That is evaporation. So the correct answer, why does the mass of the water change? The water evaporates. When the water evaporates, some of the water particle will escape from the water. So that definitely the number of particles reduce, so the mass will reduce. Question 18. Which points are the fixed points of the liquid in glass thermometer shown? The beginning, option A, the beginning and the end points of the column of liquid. For a liquid in glass thermometer, you need to know the fixed points are already fixed. There are 2 fixed points and it is constant for any liquid in glass thermometer, and these 2 fixed points are 0 degrees Celsius and 100 degrees Celsius. The reason for these 2 particular temperatures are at 0 degree the water freezes and at 100 degree the water starts to boil. So these 2 temperatures are considered as 2 fixed points in a liquid in glass thermometer. Hence the correct answer is option C. Question 19. The specific heat capacities of aluminium, iron, ethanol and water are given. 1 kg of each metal is put into 5 kg of each liquid. The starting temperature of each metal is 60 degrees Celsius. The starting temperature of each liquid is 10 degrees Celsius. Which example has the highest final temperature? So in this question, we basically have 2 types of liquid, ethanol and water. So consider one of these liquid you are taking in a beaker. Then we have two type of metal, aluminum or iron. Both are having 1 kg mass. And this metal is going to put in this liquid, as you can see. So the 1 kg metal put in the liquid. Here mass of the liquid is 5 kg and mass of the metal is 1 kg. At the beginning, the starting temperature of this metal is given as 60 degrees Celsius and the temperature of liquid is given as 10 degrees Celsius. So, when you put this metal in this liquid, since there is a change in temperature, the thermal energy will transfer from the metal to the liquid. The thermal energy will transfer from metal to the liquid. Now, by comparing the specific heat value of each metal and liquid, you should be able to find at the end which liquid will have more temperature. So here you need to know the importance of specific heat capacity. What is specific heat capacity? Let's look at the value of aluminium, which is having a specific heat capacity of 900 joule per kg per degree Celsius. That means if you have an aluminium of 1 kg and in order to rise 1 degree Celsius temperature, it requires a 900 joule of energy from outside. In other way, we can say if you have 1 kg of aluminium and if this aluminium is releasing 1 degree Celsius of temperature, means it is releasing a heat energy equal to 900 joule. So for this aluminium, 1 degree Celsius temperature means 900 joule of energy. When its temperature increasing, then it is absorbing 900 joule equivalent energy from outside. When this aluminium's temperature is reducing, means it is releasing 900 joule of energy to the surrounding. So now you look at these two given metals, where for 1 degree loss in aluminium releases 900 joule of energy, but iron, it releases only 450 joule of energy. Hence, to have a highest change in temperature or to have a highest temperature, we can consider the aluminium metal, because it will release a very high energy to the liquid than iron, because iron specific heat capacity is only 450, that is half of the aluminium. So if you consider aluminium which is putting in the liquid, means aluminium will release a high energy to the liquid. So the liquid will become warmer more faster. Now let us look at the specific heat capacity of the liquids, ethanol and water. As you can see, ethanol specific heat capacity is only 2400. That means ethanol, to increase its temperature to 1 degree Celsius, it will require only 2400 joule of energy. But for water, just to increase 1 degree Celsius of temperature, it requires 4200 joule of energy. So that we can understand, water will take more energy even to increase its temperature to a 1 degree Celsius. So that the ethanol will use all the energy released from the aluminium and its temperature can increase further more than water. So the liquid should use ethanol and the metal should use aluminium in order to get a final high temperature liquid. Hence the correct answer is option A. So in this question, basically you have to use a metal which should release a very high energy when there is even a 1 degree Celsius temperature drop, and you should choose a liquid which requires a very less energy to rise its temperature. Then only the final temperature will be very high. Question 20. Metals are good thermal conductors. Insulators are poor thermal conductors. Which description of the mechanism of thermal conductivity is correct? Option A. In insulators, conduction takes place by electron transfer and molecular vibration. In insulators, there is no free electrons. So, electron transfer is not possible in case of insulators. So, option A is wrong. Option B, in insulators, conduction takes place by electron transfer only. Again, we know in insulator there is no free electrons, so that the electrons cannot transfer energy because electrons cannot move. Option C, in metal, conduction takes place by electrons transfer and molecular vibration. That is correct. And option D, in metal, conduction takes place by electron transfer only. It is not only because of the free electron movement, but the molecules are vibrating. That is also another reason. So option D is also wrong. So only correct answer is option C. If you find this video helpful, please subscribe my channel, and the solution for remaining questions in the description you can find the video link. Thank you.